Okay, this is Sudip. I said that, he has said that I lead manufacturing and special projects like uh, high-speed railways, Mumbai coastal roads, all very large projects of Larsen Toubro. I lead the digitalization part. So one of the things that I took the offer from Suparna is I kind of understood that there will be a lot of professors from whom we all will be learning. And to be honest, I'm a born learner. But what I wanted to say that from the company's point of view is very different when we look at these models, right? There may be all different kinds of models, all sophisticated models. But at the end of the day, when I look at all these AI and analytics and the programs and the digital programs, my boss, the CEO asked me, Da, kya return kya hai? Paisa kahan se aayega? Very simple. You may say that, you've got huge amount of digital data, terabytes, petabytes you are getting. Very good, thank you very much, right? You are doing all sorts of neural networking, right? You are building models, fantastic. Another great thing, you can get the Nobel. But tell me, where is the money? Yeah, that's the question the corporate always has. Doesn't matter whether what sophisticated tool, what sophisticated company, what sophisticated professionals you have got, right? So our task is to make sure that we identify the problems first. What problem will tell us or give us money, right? Of course, we do have the data. There is no paucity of digital. There is no paucity of solutions, software, APIs. There is no paucity. And you on the cloud, petabytes of data we do have. The question is, do we identify the problem? Can we identify the right problem which will be giving money? And that money will be commensurate to my investment. Okay, before I get into this, so I took this offer to present two cases with you. Well, one is from discrete manufacturing, which is a kind of an EPC industry, and which is engineering, procurement and construction industry. And the second one, I'll be talking about another use case, which is process manufacturing. Professors will be giving lots of theories. A lot of industry people will be talking about that we have done this digital. If you ask me, next 4 hours, I'll be talking about only digital, which I do. But I wanted to, for this particular session, because it's Analytics Society of India, I thought that let me provide you a glimpse of what happened during an AI program, AI stroke advanced analytics program. And luckily, both these programs actually with McKinsey, right? So we got the best of the brains. I must admit that. We got the best of the people to do it. And I know how hard it was, but some of the glimpses I'll be talking about. Now, before I go into the slide, I've got only 3 slides. This particular slide, if you see that chariot, it is actually GPT-3 based. This is I generated through text, right? I prompted for text. With text, it gave me this. I actually said, I need a chariot run by 4 white horses, and I need to see that under the dark cloud in the background, and at the time of the dusk. That's what they gave me. So this is, again, this is a ChatGPT based picture. I wanted to tell you that we are also starting to look at, how enterprise can help or in proliferating this GPT-based engine. And we are not ready yet, and we are trying. Now, slide number 1. If you look at this particular slide, this is all about a digital program that ran from 2016, 2017, 18, 19, where we digitized through IIoT for 12,000 machines. So any Larsen & Toubro, any L&T construction site you go to, or any large machine you look at, almost 99.9% probability that it is connected, and it is giving you every second result. And actually we see that in the command room of the CEO, right? I look after the command room as well. So whenever he wants to review, whenever he wants to present it to some of the ministers or somebody, we actually do that from, and we take a huge pride in doing that. But again, that's a digital part of it, connected part of it. That's fantastic. But when it's a question of show me the money, there lies the challenge that we had. So we took up an analytics program. It's a benefit realization program, we called it. We called it SPEED, SPEED. Those are some acronym. So basically to boost the productivity utilization of the machine. Now, remember the 12,000 machines we talked about? Now, 12,000 machines, I was in Lloyd's banking at some point in time, 2008, before the Lehman Brothers crash. So Lloyd's banking, 2 TB database, if we say that we need a 2 TB, it used to be a kind of a rakhas within the company. How to get 2 TB? Right? So 2 TB is huge. Today, 2 TB is nothing, right? On the tap we get, right? So in this particular program, we got from few machines, 5 terabytes of data per month to process, right? Somebody talked about that. How do you process? What do you process? Do you need to process from the edge to the cloud? All these things, it's a different day question, not today. So what we did is, we processed 5 TB of data. But how did we process that? And how did we do the analytics program? I'm giving you a particular example. So we do have a machine called motor grader. What motor grader does is, it's a huge machine. One machine costs around 5 crore. Productivity itself is a challenge for us because we wanted to get the maximum revenue out of it, because what it does is, it'll be large heap of kind of soil. It just grades, it makes it plain, and then we compact, we make the roads, make the airports, etc. So for one, it is expensive machine. It has to work. And the more it works, the more we get the money, because everything is converted into money. Now, when we looked at the Bangalore airport case, I mean, first we looked at the entire, all the motor graders around the company. We looked at and we tried to analyze that how much this machine actually is working. What is the utilization? We looked at the ERP data. The ERP data says that 92%. That means 92% utilized. They call it productive, but utilization actually they're talking about. So our CEO went to the Bangalore airport and he saw that Bangalore airport was not progressing well. In the sense, we are not revenue generating that much. But we were showing 92% that machine was utilized. It's a fallacy, right? If the machine is working 92% and we are not getting machine, then something is wrong there, right? So we immediately started first look at the machine itself. We looked at the first one, you see that, switch on and switch off. So we had multiple types of IoTization there. So data was not a question. Question is, how do you interpret the data and get the benefit out of it? So we had this is one of the most IoTized machine for us. There are other case studies where we are using satellite navigation system actually here. This is our semi-automated machine, which is working. Only the guy who is the operator, he just does the steering and just a brake. That's it. Because it has got all the measurements, 3D measurement fed into the system. Now these are, see, I would say I'm just a dumb guy. I started with this. Business told me you are wrong. Went to this. Business told me you are wrong. So this is all about iteration and negotiation between business and us. Right? I also didn't know that. I'm a civil engineer, but still I didn't know that because it's a machine.
Was it trial and error?
It's trial and error. Trial and error, iterative, heavy learning, lot of gullies in the boardroom. Trust me, it's not easy. And at some of the times we feel that, just leave it there. Kaun magajmari karega isko. But the problem is, it's sponsored by the CEO. You can't just, there is no point of, there's a point of return. There's no return. Yeah, you have to do it. So this is an amazing project. This is just one case study I'm talking about. If you look at increased productivity, reduce waste of diesel, right? Diesel. And then I can't read it from here. So redraft the contract I talked about, right? So people behavior changing. After that, we came up with fuel sensor. Any L&T site you go to today, anything which fills in for the petrol, diesel, it has a sensor. And we uniquely manage this. And this is just one case study I'm talking about. There are multiple, but again, this is the discrete industry. Let me take up the second one. This is the process manufacturing. I call it Bibhuti. This is also done by McKinsey, by the way. We saved 50.4 CR in this program. And we paid McKinsey around 22 CR or something like that, 25 CR. So that means data was getting generated. Lots of systems are there. Data was getting generated. At some point in time, you'll have to take a call. What do you do with the data? Then we engaged with McKinsey and said that, okay, let's see what we can do out of it. So we did 2.5 months just study of the data. So we gave them data, whatever they wanted, with the chairman's permission also. And so once we gave them the data, they came up with some 20 ideas, 25 ideas. Say that, okay, fine, we can do this, we can do that, we can do this. All are identification of the problem. Again, I'm saying it's very important for analytics program. You have to identify the right problem, business problem, right? Those business problems will be giving you, which will be giving you money at the end of it. So this is one of the programs, one of the use cases that we got. One particular case I'm talking about. Here, we were, I told you that we were getting data like anything from, it is a particularly glass furnace. It's a glass manufacturing company. Glass furnace is a process manufacturer. It's like a steel. So we had around 50 plus data items from different places that were coming in. But not all 50 plus data items can be important, right? So we had a mechanism to first filter it out. We will take only 16, right? We filtered it out. Now, what is the problem that we are solving here? We actually banged our head. Is it really a problem that we are solving? Then finally we understood on the furnace, glass furnace, if there is a problem, what is the problem manifestation? Is the defect. Now how the defect happens? If the glass vortex, molten glass rotates, and if the rotation is a little high, there will be either bubble, or if there is some problem, there will be some spotting. Either bubbles or spotting. So we now baseline the data. We looked at the baseline of the data for last 2 years. And good news is, just during the COVID, we worked, and during the COVID also glass industry flourished, right? All batches, all shifts were fantastic. So data was, quantity and the quality of the data was fantastic. So we did all sorts of data governance process. So what we did is 16 data points, we saw that important. These 16 data points seem to be affecting the glass quality, molten forming glass quality from the furnace.